it's Mrs. Nelson, and we're going to talk today about urine formation. Again, I alluded the last couple of days that this unit is a little bit trickier today, so we're a little heavy on the notes today. So I haven't assigned any tasks. I will put an exit slip up that kind of ties in all 3 of the days we've done so far for you to kind of review what we've done to date. I also would encourage you to go over the notes, not just once while you're filling in the blanks, but maybe read over them 1 or 2 times to get the gist of it, and maybe even rewatch that science sauce video from yesterday. Again, it might make more sense now that we're going to break it down into its steps as well. So urine formation. So you make about 1 milliliter of urine every minute. And urine formation occurs in the nephron. So molecules are exchanged between the blood vessels. So your blood vessels in your kidneys, the renal artery brings all the blood from the heart to the kidneys to be filtered. Renal artery breaks down into arterioles, and that afferent arteriole brings the blood to that capillary tuft called the glomerulus. And again, we talked about anything that's small enough will be kind of pressure filtered from the glomerulus into that Bowman's capsule. Anything that's too large will leave via the efferent arteriole and join up with that peritubular capillary network that surrounds each nephron. And that peritubular capillary network is there so it can catch all the things that are reabsorbed back into the bloodstream and take that fresh blood full of just the things reabsorbed that we want to keep back to the heart via the renal vein. So urine formation again happens in the nephrons, and it's exchanged between blood vessels and nephrons. So urine formation consists of 3 steps. So the first step is pressure filtration. The video yesterday called it ultrafiltration, but we're going to use the words pressure filtration, and I kind of equated it to kind of putting your finger on the end of a hose, right? You kind of ramp up the pressure that way. Selective reabsorption, so we're going to select the things that we want to keep and reabsorb them back into our bloodstream. And the third part of urine formation is tubular excretion or tubular secretion. So we've got a last-ditch effort to put anything in or take anything out of that what's called filtrate. It's not quite blood, it's not quite urine yet. That filtrate and reabsorb or add things like penicillin or and other antibiotics to it to be excreted in your urine. So here's a diagram, and this is kind of a diagram of your nephron. And you'll notice in yellow that we've got our cup, our Bowman's capsule, our proximal convoluted tubule, our loop of Henle, our distal tubule, our collecting duct, and then the layers of the kidney. So this above the dotted line is your cortex, and then we have our medulla down here. This here I've rewritten over on the side. It says increasing saltiness. So the way this happens is by setting up gradients of kind of saltiness, and water will kind of passively flow out if it's in a high concentration in the urine. So it sets up these concentration gradients, and then some things are allowed to just flow because of that concentration gradient from high to low. So here's our afferent arteriole coming into our glomerulus, that capillary tuft, and anything that's too large like proteins or red blood cells will leave via that efferent arteriole and again join up with that capillary network that would be a mess around here. We've got this kind of, you'll see this dot here, this is called the juxtaglomerular apparatus, and this is what increases that pressure. So like I said, that pressure filtration is like putting your thumb on the end of a hose, and it ups the pressure coming out of your hose. The juxtaglomerular apparatus releases a chemical called renin that ups the pressure in those in that glomerulus, and that increase in pressure is what will force anything that's small enough through into the Bowman's capsule. So you can see here that things like sodium chloride and glucose, and the thick arrow means it's actively reabsorbed, active transport, so it means it needs energy, are reabsorbed from there. Other things like water are passively reabsorbed, and potassium. Then we come down here, you'll notice this is the descending limb of the loop of Henle. Water is reabsorbed from that passively because it's the ascending limb over here, this part that goes up. It's actually impermeable to water, so it reabsorbs salt, and that reabsorption of salt makes that increasing saltiness, makes that concentration gradient, and then the water just passively flows out after it. The distal convoluted tubule, again, we're taking out Salt, excess salt, we're putting in excess salt. Water will be filtered out. This H plus, this hydrogen ion, that would be actively reabsorbed from the blood if we need to lower the blood, raise the blood pH, because hydrogen ions contribute to the acidicness of the blood, which is below 7. So it would be like 2, 3, 4, 5, 6. So if we take hydrogen ions out, it raises that pH. Bicarbonate that's a base. So that would make the blood kind of basic, so above 7. So if we're reabsorbing that into our bloodstream, we are going to raise our pH as well. So raise it above between 7 and 14. And anything that's left by the end of that distal convoluted tubule goes into the collecting duct here, and this will collect that basically urine from several nephrons and take it into that renal pelvis so it can go down the ureters for storage in the bladder. But you'll notice that water and a little bit of urea can be reabsorbed from that collecting duct as well. I encourage you to spend a little bit of time with that diagram trying to understand what's happening. So pressure filtration is the first part of urine filtration, and the high blood pressure in that glomerulus. So again, because that juxtaglomerular apparatus is releasing a chemical called renin, it will actually up the blood pressure. It forces small molecules, so water, nitrogenous waste, nutrients like glucose, and ions like salts into the Bowman's capsule. We're going to do a concept map in the future. So the concept map is going to ask you what is forced through the glomerulus into the Bowman's capsule. So this list of things here are what you're going to want to write down in that. So we don't want to lose all our water, all our glucose or nutrients, and even all our salts. We don't want to lose all of those constantly. So we would quickly die of dehydration and starvation if we filtered out all our water and our sugar. So those substances must be reabsorbed back into the blood. So once we get this pressure filtration and we filter all the things that are small enough, the next part we need to make sure that we reabsorb the things we want to keep. So that'll be in that selective reabsorption. It's important to note that large molecules are unable to pass. So blood cells, red blood cells, white blood cells, platelets, proteins, those will remain in the blood and leave the glomerulus via that efferent arteriole. That efferent arteriole becomes the peritubular capillary network that's going to be there to catch all the things that we reabsorb, and we're only going to reabsorb the things we need to keep that blood nice and fresh. So the small filterable molecules that are forced into the Bowman's capsule, it's not blood anymore because we filtered out all the blood cells. It's not quite urine yet because it's still got all the things like sugar and water that we need. So it's called filtrate now. High blood pressure is necessary for that filtration. So this is accomplished through the functioning of the juxtaglomerular apparatus. So this is that special region of the afferent arteriole that we kind of drew on our map, our diagram on page 13. And it will, if necessary, release a chemical called renin to increase the blood pressure. People with kidney disease often have high blood pressure because their juxtaglomerular apparatus is constantly releasing renin. Oh, there we go. Selective reabsorption. So if the kidneys only did pressure filtration, again, we would die from water and nutrient loss. So once that original filtrate is made, the next task is to reabsorb molecules from that filtrate back into our blood that are needed by our body. So water, nutrients, and again, I've written glucose under there, and some salts. The molecules that are reabsorbed move from the proximal convoluted tubule to the peritubular capillary network, so back into the blood. And it's actually really quite efficient. So every minute, about 1.3 liters or 1,300 milliliters of blood enters the kidneys, and 1,299 milliliters of blood leaves. So 1 milliliter every minute becomes urine. So what kinds of things get reabsorbed? So we reabsorb water, nutrients, and some salt. So again, I talked about that concept map that we're going to do in a few days for Marks. When you're looking at what gets reabsorbed, there's a list there. What doesn't get reabsorbed is some water, waste, and excess salt. So waste would be things like urea. So the non-reabsorbed material continues in the nephron through the loop of Henle, and reabsorption is both active and passive. So some of it active, again, requires ATP or energy, and often a carrier molecule. Passive is just when it diffuses from high to low. So that's why it's important that we set up that concentration gradient. So things like chlorine ions and water. So that tubular fluid now enters the loop of Henle. And the primary role of the loop of Henle is to reabsorb water. So over 99% of water in the original filtrate is reabsorbed by the nephron during urine formation. So salts, so NaCl, so sodium ions and chlorine ions are also passively and actively reabsorbed. And this concentrates the urine, allowing it to become hypertonic to the plasma. And hypertonic, again, hyper means greater, tonic is strength. So again, and I'm going to kind of make this point here. If we have 2 milliliters of salt and 98 milliliters of water, let's say that's 2% salt, 98% water. If we reabsorb most of the water and we absorb kind of 48 milliliters of water, we now have 50 milliliters of water. So that salt is the same amount, but it's concentrated it. So 2 out of 50 is now, that salt solution is now 10% salt. So it's just really important. There'll be questions on your unit test that say, why does it look like the salt's getting more concentrated? Well, the salt hasn't changed. The amount of salt hasn't changed, but it's now being dissolved in less water. So it concentrates that salt. So just something to point out there. The last part of urine formation is tubular excretion, or sometimes called tubular secretion. So I'm just going to I've updated your book, so these page numbers are no longer valid. So I'm going to take that out, and I apologize for the ones in the notes section. So this is an active process. So again, that word active means you need energy, by which other non-filterable molecules can be added to the tubular fluid so that these wastes can be excreted in the urine. So this occurs in the distal convoluted tubule. So secreted substances could include chemicals like penicillin, which is an antibiotic, histamines, hydrogen ions, ammonia ions, and that fluid, once we've reabsorbed all the other things, now enters the collecting duct. The collecting duct in the cortex, the fluid in the collecting duct is isotonic, or equal strength to the surrounding cells. So again, if we're looking at our collecting duct here, up here it's going to be equal strength, but as it gets into the medulla, the fluid is hypotonic, or less strong to the cells of the medulla. So therefore, water can passively diffuse out of the collecting duct again. So if you're dehydrated again, we're going to reabsorb even more water from what would become our urine. So the tubular fluid, which we can now call urine, passes from that collecting duct into the pelvis of the kidney. It then, and that's that hollow center of the kidney, enters the ureters or ureters for transport to the urinary bladder, where it can be stored until it can be released from the body. So there's no assignment for today, but there will be an exit slip posted in Teams. So see the assignment tab in Teams for that. Thanks very much. Take care.